Welcome back to Maths with Mrs. J. Yes, I have greeted you with the unit circle yet again. I'm sorry about this, but it was a necessary evil. We are talking about some of the properties of our inverse trig functions. And in order to think about those, we do need to refer back to the unit circle and think about what's going on there. We're also going to start thinking about how we would solve trig equations, both within the actual domain of our inverse trig functions and with a general solution. Remember that anywhere on your unit circle could be described in an infinite number of ways. So this point here that has, an x value of whatever, 0.8 or whatever, and a y value of about 0.6, that could be accessed by either saying theta or 2 pi plus theta or 4 pi plus theta or 6 pi plus theta, or we could go around backwards and say negative 2 pi plus theta, etc. There are multitudes of ways of describing a point on the outside of our unit circle. Just remember, cosine of an angle is the x value, sine is the y value, and tan is the y value divided by the x value. What we're doing when we're doing inverse trig functions is in effect, we're saying the y value is this, what is the angle? Now, when we're talking about the angle here, we are talking in radians. We are talking about the distance around the outside of the circle. If you were to get approximations for any answers using your calculator, you would need to ensure that your calculator is in radians, not degrees. Ideally, we try not to work in approximations. We try to work with exact values whenever possible. And yes, you need to still know your exact value tables for your sine, cos, and tan, because we're going to use them in reverse. Okay, let's just have a look at some of these properties of our inverse trig functions, and let's think about why that is the case. Inverse sine of negative x is negative inverse sine of x. Okay, let's just think about an example to actually help us process that. So if I'm saying inverse sine of negative 1 on root 2, bearing in mind, if we're taking inverse sine of something, it's going to have to be between negative 1 and positive 1, or we can't find the angle, of course, because sine is always between negative 1 and 1. All right, inverse sine of negative 1 on root 2. Our inverse sine, we're always talking about from negative pi on 2 to pi on 2. So we're talking about our fourth quadrant or our first quadrant. Obviously, with sine, if it's positive, it would be a first quadrant answer. And if it's negative, we need to state it as an angle between 0 and negative pi on 2. Just thinking about this, well, thinking about our table, we know that sine, inverse sine of 1 on root 2 is pi on 4. Or we should know, let's put it the other way, that sine of pi on 4 is 1 on root 2. Or root 2 on 2, whichever way you want to remember it. So inverse sine of 1 on root 2 is pi on 4, right? That's in our positive answer in our first quadrant. So to get the similar result in your fourth quadrant, we're just going to use negative pi on 4. That will work. But lo and behold, what have we got? Our inverse sine of our negative value is actually negative inverse sine of the value. That happens because what happens is if you're doing a horizontal reference, the y value here and the y value there, this will be positive, this will be negative, so the angle there is positive, the angle there is negative. Just remember when you're doing inverse sine, inverse cos, inverse tan, what you're talking about is what is the angle. And we have a specific section of the graph that we can talk about here because we're doing inverse sine, cos, and tan. If we want to build it up to a general solution, we're going to take that value and add 2k pi to it, or whatever the case may be, depending on whether it's sine, cos, or tan. Inverse cos of negative x is pi minus inverse cos of x. Okay, well, just thinking back to our previous video, we said that for inverse cos, we go between 0 and pi. Remember that? We go between 0 and pi for inverse cos. So, if it's positive, you'll have that first quadrant result, which will be between 0 and pi on 2. That's quite easy to do. If you have a negative value, so if you're wanting to work out inverse cos of, say, negative root 3 on 2, we must be in this second quadrant, mustn't we? To have an x value that's negative, we're only given the first or the second quadrants because of the restrictions on our range and domain. So what we're talking about here is a second quadrant value. And we know from my videos about what I call the horizontal reference, to get that angle, you do pi minus. That's exactly what this is. Right? The angle that you get if you have a negative cosine is going to be pi minus the angle that you get in your first quadrant. That's really what this inverse sine, tan, and cos stuff is about. Inverse tan of negative x is negative inverse tan of x. That's similar to the sine one. Remember that for inverse tan and inverse sine, we're going from negative pi on 2 up to pi on 2 for our range. And then finally, we've got this little gem here, which is, it makes a lot of sense, but you need to think about it for a bit first. Inverse sine of x plus inverse cos of x is pi on 2. Okay, well, let's think back to our, let's just get rid of some of this mess. Think back to our unit circle when we started and we were doing what I called a horizontal reference. So we put this angle theta next to here and we said, okay, all right, we've got pi on 2 minus theta would talk about this angle here, would be pi on 2 minus theta. So what we're going to do here is we need to think about sine and cos of an angle. We should know that sine of pi on 2 minus theta is the same as cos of theta. We learnt that, didn't we? We learnt that if you're doing your what I call the vertical reference, then sine and cos swap over. Cos of pi on 2 minus theta is sine of theta. Now, for cos and sine, when you're talking about inverse sine and inverse cos, the only overlapping quadrant you've got is quadrant number 1. Because if cos is negative, we're talking about that quadrant. And if sine is negative, we're talking about that quadrant. All right? So the only overlapping quadrant, if you like, is this quadrant here. And look what's happening. What is actually happening is that the angles are going to add up to pi on 2. That's really what this is saying, is the two angles of cos and sine will add up to pi on 2. All right, it sounds complicated, but it's actually not. Even if you think way back to when you started trigonometry with right angled triangles, even if we go back to degrees, for example, all they're really saying is in a right angled triangle, if this angle here is 23 degrees, this angle here will be 90 minus 23. That's really all they're saying. Okay. Of course, we're talking in radians here, and of course, we're talking about things that are a little bit more interesting than just a right angled triangle, but that still fits. Okay. In our next video, we're going to start talking about solving trig equations using these inverse trig properties and our exact values and some generic ways of talking about certain parts of the unit circle.